Welcome, everyone. We will get started in just a moment. So welcome to the Gray Decision Intelligence very last masterclass of 2024. Thank you for joining us as we present how artificial intelligence, machine learning, and other new tools can model the impact of program decisions on your institution's future. We have a full house today, so I ask you to please put your questions in the Q&A section or in the chat. We will get to as many as possible during the presentation and then follow up on those we miss after the webinar. Everyone in attendance will get a link to access all of the recorded videos and slides in our 2024 Masterclass series. And without further ado, I will turn things over to Zach Paz, who will do introductions and get us started.
Awesome. Thank you, Marianne. Welcome, everyone. Thank you for joining us today on our last of our masterclass series. We're excited to share some very exciting things that we've worked on, but areas that we know can help specifically in higher ed. I'm Zach Paz. I'm Executive Vice President for Product and Chief Operating Officer at Gray, joining you from Phoenix, Arizona, the greater Phoenix area. And I have Youssef joining me. Youssef, you want to say hi?
Good afternoon or good morning, everyone, depending where you are. My name is Youssef. I'm a manager of data science and product, joining here from the Pittsburgh area.
Awesome. All right, so jumping in, we're going to be talking about some applications of advanced analytics, machine learning, artificial intelligence in higher ed. This is absolutely not an exhaustive list. This is a list that we've seen a lot of value, especially working with some institutions over the last decade. And the way we've kind of think about where they fit are what areas can we help around budget and planning? What about operations and marketing? And then finally, how do we support academics? And so we'll go through a number of different techniques, tools, data to support these three areas specifically. First, I want to talk to you about one that always comes up is understanding pricing for your programs and eventually even courses and maybe other delivery methods of your program and your curriculum. So one that we've done and worked on with a lot of institutions is what we call value proposition and pricing. And the way to think about this is the fact that, yes, price is an important thing, important concept to wrap your head around, but also knowing that students are making decisions with price, but also with a whole bunch of other things about an institution. And if this wasn't the case, we wouldn't have students be going to some of the highest cost institutions. So we always like to think of this, and we suggest thinking about this in collaboration. And what you're really trying to understand is how will changes in your price and other value propositions affect the demand for your program. And there's a whole bunch of other things, and we'll talk about some of the pieces. Specifically, what are the value elements that the students are making their decisions on, and ultimately you can get to how price sensitive is the market, but also how strong is your brand. And so this type of analysis can really help illuminate those areas for you. There's many different techniques to go about this. In our case, what we found very helpful is using a series of surveys and then analysis on top of that, from identifying what value proposition students actually value. So the first thing is you need to find out what that list is. So you first want to generate a list of ideas. There's a couple of ways you can go about this, as maybe the leadership comes together and says, okay, we think these are the most important value propositions, including price factors that our students are making. You can go to faculty, ask what they think. You can even go to current students and prospective students to really gain a strong and comprehensive list. You then want to screen that list down There's a couple of different ways to do that, and I'll talk about one in the next slide. But ultimately, to get a short list, because what you're trying to do is get to a offer that you can go to market with and test in the market. And that's where you get to the discrete choice. And I'll talk about that in a couple of slides. What you really want to be able to do is get to how is this going to help me support decisions I make around what levers I have as an institution to pull, whether that's a tuition lever, increasing, decreasing, whether that's including maybe fees, scholarships, or it's things that you need to invest in. Maybe it's investing in different types of curriculum, maybe updating your facilities, accreditation. And so what are those different pieces that change the value and ultimately change the choice of the student to come to your institution versus another choice that they might be making, right? So how do you actually get to a short list and really understand what are the most important value propositions? And one technique to do this is called max diff. It basically gives respondents to a survey two options that they need to select. One is out of a list of benefits, what's the most appealing and what's the least appealing? And the reason you want to go through this type of max diff analysis rather than saying how important is this value ranked from 0 to 5, in many cases, students might say, oh, 5 for every single one of those. So what you're trying to do is actually differentiate what's the most important by making them choose what's most and least important in their decision-making process. So right off the bat, getting this type of analysis done can really inform what the student is thinking in terms of what they're focusing on to make their decision, and and ultimately that will then feed the next part of this analysis, which helps you get to the value of those attributes. And that's where you get into a technique that you can use called discrete choice modeling, where you can review your institution's brand versus maybe some peer institutions or competitors, and then list out a few features of your program, including price features, and have the student or the prospective student or the respondent select which offer is more appealing to them. And then you can help validate that with understanding how much they would actually consider that offer, versus option A versus option B. And what you ultimately get to is through logit modeling is to actually get to the analysis that says, okay, for when you go through a series of results for this, what is the actual value of increasing or decreasing tuition? And how does that relate to having accreditation A versus accreditation B, for example? Or how is your modality changing the decision? And so what you're able to do is see how does demand change based on what offers were selected through hundreds of respondents for this. So one thing that you do need to make sure is that you're able to get large enough sample for this, but what you're able to get from it is highly valuable and where there's a shift in demand. Right? Now, if you just focused on demand, you could be seeing some very, it could be leading you to some potentially troubling results. So for example, let's just, as an example, say decreasing tuition to $10,000. Well, obviously, I think that we can all guess that decreasing your tuition to a very low amount might increase your demand, but is that actually sustainable from an institution perspective? Can you actually run an institution decreasing it by 10,000 or even to 10,000? So you always want to keep in mind the revenue side as well, and building that into your use case. So not only are you looking at the demand features and how that changes, but how does that influence the overall revenue and ultimately sustainability of those levers that you're pulling. So you want to look at not only how does starts change over time, but how does that influence margin as well. So I think if we all wanted to get more students, I think one thing we can think of is just lower costs, but can that actually work in terms of being a sustainable financially? So again, the ideas here is it's not just about price. What else is in the student decision-making process, and how can we get to understand what value the students put on those in their decision-making process? Right. So I'm going to switch over to Youssef to talk to you about some other techniques that we have around location and geographic marketing optimization.
Thank you, Zach. Another application of applying advanced analytics into your data or other data is to answer the question is, what is the best site for a new campus or a regional center? Think about a satellite campus that you would like to build, or if you're on a bigger scale geographically and you just want a whole new campus nearby you, one of the questions that's come is, where should this new campus be? Many of the questions start with some, idea of where you want it to be. So finding the market that you want to put your new campus is usually the best or the first step. And then looking into your current students and how your distance from where they come from affect their enrollment would be the second application to look into. So where we start usually is looking at your current students, where they come from, and see the effect of the distance, and see most of the time from what we see from our analyses is up to high percent, I would say 70 to 80% of the students come from within a certain area from the campus. Let's say for the sake of example is 100-mile. Then what you would do is analyze where they come from, where their location attributes are, and then what programs they go to, and then use that information to build a model to evaluate a new market using your existing data. One thing to keep in mind about this is cannibalization. Most of the time, cannibalization is talked about. If I offered a new program, then some of my students will go to that new program, which, cannibalize my own students. Well, this is a different one. What this is saying is if I put a campus, a satellite campus from my original campus, will some of my current students who are coming to this campus go there? And that application of cannibalization is very important to take in consideration when creating whatever location model you're doing, because at the end of the day, the net increase of your student is what you care about. Otherwise, you're just switching the location of the students.
Youssef, before we proceed, we do have a question if you have a moment.
Okay,
Do you mention logic regression to analyze these data? If yes, what is the dependent variable?
I think that question was to Zach's portion.
Yeah, so that we're trying to understand if it's a yes or no. They're going to accept or not accept the answer, the offer. That's what we're modeling. And then for sample size, we've been able to run models with about 125 to 200 responses. 125 on the low end, but you want at least 125 for that specifically.
Thank you, Zach. Thank you, Marianne. Okay, going back to the location selection. Not going to go over that one more time. So let's go to the next slide of how we can approach this. One of the richest data sets, next slide, please. One of the richest data sets is the demographics and the US Census data by tract. Going all the way to the smallest building factor is one of the best practices when building a model. So census tract in a geographic sense is the smallest one. And for those who are not aware of it, it is about half the size of a zip code. So there are 75 to 80,000 census tracts in the United States. And the public data about the US Census that come out of it include data by the census tract about how many high school graduates are there, what is the total population, the breakdown by demographics, the breakdown by income, by household, by people, by how many cars on average these households in this census tract have. So that data would be part of the X variables for those who are interested in the mechanics of the model. You're also interested in knowing the competitors. If you're putting your new campus in a satellite location, look around. Are there any schools that offer the same programs you're offering? If so, are you supposed to offer the same program, or are you looking into a different mix of the programs? Also look into the demand of the students and the demand of the employers. Many of the time when we see a satellite campus, it is targeted for, workforce population, or basically people who are working and want to attend a course of two, or take a program in the night course, or online, and they want to put a campus over there. So how is the employment for your programs in that satellite location? What is the Google search demand for the students that are looking for those programs in that satellite locations? That's on the X part, basically. On the Y part of what you're trying to predict, or what you're trying to build a model on, is how many starts you're going to get. Again, if you remember in the previous slide, I said you start by how many starts you already got from your current market, and use that to train how many starts you're going to get in a new market. And not only starts, completions, or grads, of that matter. Distance play a big effect on this. Many of the factors are good where they are, but the furthest they are from your location, they have an additional effect on their importance to the model. So a student demand, if you have it a mile away from you, versus amount of student demand you have from 10 miles away from your campus, both could be the same value of the amount of Google searches, but the distance that they are applied to your campus may have a big effect. And this is where a distance adjusted analysis can come in handy. Taking both entrance, the X and the Y, go into a machine learning model, and can give you a model start by census tract, which then you can aggregate to the location you're looking at. It could be counterintuitive at the beginning. When you try to do it, you may get, oh, I'm going to get 0.65 students in the census tract, but that, when you aggregate, it does add up into a sensible number by campus location. Next slide. Yeah, other things to consider. When I mentioned the distance effect on the numbers, or when I mentioned the distance adjusted factors, what you see on the right-hand side is one of the outputs that you may find, for a specific location on the East Coast. You can see that, let's say we're looking into the demand, the closest they are to that location, the more the demand there is. Taking a visualization like this is not only nice to the eye, but it can also be helpful when you making the final decisions. So the next step would be, if you want to go to a real estate agency and say, well, hey, I did this location analysis, I know this area within X miles from the center of that area could net me the highest amount of starts. So let's try and find out. And this is where other qualitative inputs can go into, including the convenience to the public transportation, the crime rates, or if there are any new competitor locations that were not captured in the quantitative side of the analysis. Same logic or same modeling techniques can be applied to look into the marketing optimization. Right now, we do have the opportunity or the ability to be as precise in our marketing as possible. If you're using any digital marketing platform, you can target a specific area nicely, which was not possible back in the day. There's no, just target everything with a billboard or a TV. But now we are. And since we can apply the same model to evaluate the lead opportunity by market, or to evaluate the spend. Similar approach when we looked into the census data. and we analyze that against our starts, we can look at a similar data and analyze it against our leads, and then find out how many leads would I get from these different locations if I want to go and market there. The other thing is you can put some numerical value into how much you spend and see if I spend X amount of dollars in that location, this is how many leads I'm going to receive. But let's use the same location and apply different monetary values on how much marketing I'm going to spend, and then see how much the effect. You tend to see some diminishing returns at some point, but that all depends on your analysis.
Okay. The next application we're going to talk about is skill trends and potential gap analysis. And this has been becoming increasingly more important and prevalent in questions that we're getting from institutions we work with. But what skills are needed in the workforce? And does what we're teaching align with those needs? Ultimately, to understand if there's specific curriculum or programs that we're missing, and help potentially prioritize new programs as well. So the first thing is collecting the data on this. And in many cases, for any of this advanced analytics, machine learning, AI, the models are only as good as the data that they're built on, right? And I'll continue to harp on that as we go through some other use cases. So where can you get some of this information? There's very future-looking things that you can be looking into where there's funding happening through DARPA. There's reports like the future of work, and specifically things even coming out from NASA, where you can identify some very future-looking potential skills needed in the workforce. In many cases, those are going to be very high level of education required in those. But it always good to keep an eye on where things are moving, because as those things become more commercialized, they then go down the education level and become easier to, or not easier, but become more available to curriculum specifically. So what other data can you look at? Obviously, job postings data is very important. Understanding who's in what market, what jobs are they posting, what skills are they looking for, and ultimately have an idea, a way to quantify that, both from a count, but also potentially from a wage potential. There's other things to consider, like the MOOC data from Coursera or edX or any of the other online platforms. So where can you get this information to help you identify what skills are needed and being taught? Ultimately, what you need to get to, or a way around this issue of understanding what's truly needed in the market and what you're offering and where there might be a gap, is aligning this to a single skills taxonomy. And that's probably one of the hardest things to do. But when you have a skills taxonomy that you are ready to work with, it's then aligning the data from your internal, what do we teach, from your descriptions, your courses, into using natural language processing to then codify all of the relevant skills for those programs and courses. In all of these cases, you're going to want to have subject matter expert review to make sure that what the model is producing as relevant to your programs and courses is actually true. And then on the other side, you're going to want to do the same thing. Align the job postings data or other data sources to the same exact skills taxonomy, so that you have an apples to apples comparison of what is being requested in the market from a quantity perspective, but also potentially a wage perspective. And then what do you have that covers that need? And then where are the potential gaps? And again, one of the most difficult parts is selecting and identifying what the appropriate skills taxonomy you want to use to do this, but you really do want to align them to identify those gaps. So another application we're going to talk about is enrollment forecasting. There's a lot of different use cases for this, but especially now when you're thinking about tightening budgets and you want to make sure you are budgeting appropriately for the next term or academic year. Ultimately, you need to understand how many students are going to enroll. And that's a very hard thing to estimate. There's many ways you can go about that just by using different attrition rates and ratios from your applications. But is there a next step that you can take to ultimately create a prediction at the individual applicant level to say what's their probability of actually enrolling at the stage they are in the funnel? So some of the things that use cases is also to identify what admissions activities lead to higher probability of enrollment. And so that you can identify, okay, if we want to focus this area, or we need to add additional resources because we know if an applicant gets through A, B, and C, their probability of enrollment is much higher. That can help you, again, leverage different resources and give you a way for an area where you want to invest additional resources, right? That might be from an admissions perspective, or maybe it's a marketing perspective. Maybe you're seeing higher levels of enrollment than you're expecting, and the model is saying, oh, you're going to meet your goals for enrollment, and you don't need to spend as much on marketing. Or maybe you're on the other end and you want to invest in additional marketing to fill a potential gap. So ultimately, how quickly can you respond to changes in your enrollment funnel with different resources? And then you can even get all the way down to the delivery. How many faculty might I need? What additional facilities might I need? So it can really help inform a lot around resources at the institution. One thing you'll want to do is develop the data and make sure you have access to the data that will help build the model from an individual applicant perspective. So many of this data can be found just in your CRMs, for example. So looking at students, where are they located? What was their high school GPA? How far are they from your campus? What events have they attended? How many times have they talked to an admissions counselor? What additional marketing efforts have you been putting in during that time frame? And then any other variables that you might see relevant. But ultimately, again, making sure that you have the data available, because the model will only be as good as the data that you have. So what might a process look like for this? So again, collect and validate the data from a CRM or other data sources. You'll want to test and engineer features, ultimately looking at what features really influence the probability. You'll want to start testing multiple models and identifying which models, or maybe multiple models, and assemble models together to get to the highest level of accuracy. Once you're comfortable with the results, you'll then generate enrollment predictions, right? And the nice part about doing it at the individual student level is that it has many applications, not just helping you forecast enrollment, but also could be information that you give to the admissions team and other key stakeholders. So visualize the results, ultimately create a report, dashboard, but can you give the admissions team or the admissions counselor, admissions representative, the probability right where they're interacting with the student, so that they know, okay, maybe we need to see if they'll come for a campus visit if they haven't already done that. And again, to ultimately inform those strategies around admissions and even marketing. And this is an ongoing thing. Student records in your CRM are updating frequently. So you want to develop a process where you can update those results on a frequent basis, and then ultimately go through this whole process again as you get better and understand how the data works, and understand what different features might help increase the accuracy of this prediction. So again, as I've started to allude to, some of the results and analysis will help inform the admissions team of student prospective specific activities, right? So if you can get to the individual student record, provide that to the admissions team, does that help them communicate different values that they need to at different times of their student in the funnel, so they can be better at their job? Evaluate recruitment strategies. So are the activities that you're prioritizing, are those strong for enrollment or not? And what other activities might lead to better strategies? I mentioned budgeting, marketing, and admissions. Are there additional resources that you need to add, or are you meeting your expectations and you can hold back on additional marketing? Talked about the different resource planning, whether that's faculty or facilities. One thing you always need to get into is budgeting for the next academic year. So can this help you estimate tuition revenue? And then finally is allocate additional, maybe financial aid resources. Maybe you need to meet certain goals and you're able to allocate more financial aid to help students get across that finish line and ultimately enroll. So next application we'll talk about is predict program size with pro forma financials.
Thank you. So there was a question that came that I thought I'm going to answer verbally instead of actually typing down. So what is the difference between machine learning models and econometrics analysis, if any? Well, there are a few differences. The one that I can name, probably I would say three. The first one is the objective. Econometrics models or analyses tend to have the objective of fitting the data or understanding the relationship between the variables to the y variable. While the machine learning model, the main objective is optimize the accuracy of predictive power. The second thing I would say, the big data component, machine learning, given that they're used different algorithms from the econometrics world, they tend to be able to handle big numbers. So in the next part, I'm going to mention, for example, one of the models we have handle over 5 million data points. And an econometrics model may not have the robustness to do so, or maybe it does, it depends on the data type, obviously. And speaking of the data type is another difference where machine learning are able to take textual data, and they are able to take different types of data at the same time, including time series, textual, even dummy variables, if you may say, while the econometrics tend to be more in the statistical data realm. And I would say lastly, the usage, it tends to be predictive machine learning model and description of a policy and the policy effectiveness comes from an econometrics model. So that's what comes to mind, and I wrote half the answer, but I said, well, let me say it for everybody as well. All right, so one of the applications that we're going to cover today is predicting a size of a program as an application of advanced analytics. Well, I'm going to take you back for like 10 seconds to master class 1, master class 2, and master class 3 to talk over the entire academic program evaluation system. You look into your mission of the institution, you look into the academic metrics, you look into your markets and see is the markets, their demand, is there an employment data for it, do you have a labor shortage for it or not? And also you look into the margins. How much does it cost to teach this class? How much revenue, how much contribution I have from my all programs or all courses or all sectors that then can be applied to overhead and to pay for everything else at the institutions. Next slide, please. Usually after you complete this program evaluation process, look into all the data, you talk to the appropriate people, and you follow the process overall, you most of the time end up with a few things that you want to take actions on, and some of them are the following. You'll end up with a list of new programs you want to start as your institution. You'll also look into your current programs and end up with a list of current programs you would like to grow. They have a room to grow, and you've seen the demand, you think you're not getting the fair share, et cetera, et cetera. And lastly, for the other programs that you don't want to grow, you want to see, well, I want to review them further and see why are they acting the same way they are. Having that list, next slide, please, usually is followed by the following questions. If I want to start these programs, how big will they be if I start them in my institution? And for those programs that I want to grow, how much growth can I actually get? Can I get 3 times the number of students I have? Or can I get, just an extra 30%? And for those programs that I want to review and see how they are performing, one of the questions, like, am I getting the fair share of the market in terms of the size? In other words, am I meeting my potential knowing the size? To answer all of those questions, you really need to know what's the potential size of a program if you offer it in your institution. How do you go around that? There are multiple ways. In the past, we used to say, well, let's take the average size nationally, or maybe taking a step further, let's take the average size in the market, in the state, the average size of a group of institutions and a group of a consortium or some sort of that, or take the median just to avoid the big players that come in and skew all the numbers. Taking it into a little bit more advanced, well, let me take a look at what institutions that are similar to me in many characteristics and how big are those programs are in their institutions. Am I matching them? Why are they higher? Why are they lower, et cetera, et cetera? Or you can see, which I think it's one of the creative approaches, to look into the accreditors data, that they receive that in overall, they have, or the schools that have this program with us that are accredited, they have this size. But right now we do have the power of AI and the power of machine learning. So the future of estimating the program size is to actually build a machine learning model. How do you do that? One of the rule of thumb, always start with a conceptual model before you build a technical model. You want to predict the size of a program at a school. Well, there are 2 sides of that. There's the program, and then there is the school. When you look into the school, many attributes that describe the school may affect the size of the program. For example, the size of the school itself. Is it a huge school that has 20,000, 25,000, 30,000 students enrolled? Or is it a smaller school that has, 2,000 to 7,000 students enrolled? On average, what is their program size tends to be? On average, what's the median size of their program? Do they have programs that get hundreds of students, or do they only tend to have 10s and 20s? So what's the 90th percentile all the way to the 10th percentile, just to see that size of the school based on their program? This is how much it is. What sector is it? Is it public? Is it private? Is it for profit? Is it not for profit? These are all factors for the school. What is the portfolio of that school? Is it a healthcare oriented institution? They offer a variety of healthcare programs, or is it an engineering oriented institution, or is it an art oriented institution, a liberal art, et cetera, et cetera? What's the selectivity? There are data about how many applicants the school receive, how many applicants the school accepts, and how many applicants of those who got accepted actually enrolled. These are all data that are available to tell you the selectivity of the school. Same thing about the student type. Do you tend to attract, professionals, people who are 25 years and older, or do you have more traditional students? Same thing with demographics and how demographics apply to the program. What is the location of your school? This is about the school attributes. Look into the program attributes, similar conceptual model take place. What is the size of that model? Does it tend to be huge? Like, I'm gonna throw some names in here, MBAs and MSWs, etc. Or does it tend to be smaller on the size? Think about the history of jazz music as an example. Same thing, going back to looking into peer institutions, I have this program. I want to start it. I don't have it. Let me look into other institutions that have it and how big that program is it in their institution. Looking into things that make them similar to you, include location, include the size, school to school, include the Carnegie classification, include US News, and some other variables. Same thing with the type of the, no, not yet. Same thing with the type of the program. Is it fitting my portfolio? If I am a, excuse me, if I'm a liberal art oriented institution and I want to offer a new CS and computer engineering program, is it fitting my portfolio? Am I creating a whole new portfolio? So I will take that into consideration. But currently, is it fitting my portfolio or not? And other data that go into what describe a program in terms of the size include the modality of the program, other market data, including the competitors in your area, and other characteristics data, including the fit to your demographic mix. These two buckets of variables go into a machine learning model, and then you can produce a size of a program as an institution. Whenever you do, make sure to design the appropriate validation methods. There are a variety of algorithms that can actually tell you whether your model was biased or not. One of them that has probably one of the most appropriate names is a confusion matrix, because it's confusing. But if you take the confusion matrix and actually visualize it like the way I have in here as an example, you may actually get to see how that is relevant to your accuracy. So what we see here for as an example, on the left-hand side, the model predicted a group of programs to be large programs, while their actual program sizes, 77% of those that were predicted large were actually large, and 19% were actually medium, and only 3% were small and very small. Think about that. If you come from the statistic world, this is your false positive. Same thing looking on the right-hand side. The model predicted, as an example, a very small as a category for these programs. Actually, 81% of those programs that the model said they're very small are very small. And 18% are small. And only 2 point some sort of decimal in here, we get 0, are medium or large. And again, if you come from the statistic world, this is considered false negative. I'm going to assume I'm going to be interrupted with questions. So let's go to the next slide. So knowing the predicted size is the anchor of creating your pro forma to launch a new program. Or even if it's a current program, knowing the predicted size is an anchor to see how much growth you can receive from tuition side, from the state if you get a state appropriation, et cetera, et cetera. So taking that predicted size that we just built, then look into the cost to teach those students that you're going to expect them to come to you. You can end up with producing a pro forma financials. Next step. Why do you need an automated and robust pro forma financials? Many schools have done pro formas, I assume. Many departments have done it. They all have their own approach. So one of the things is it takes a lot of time. So when you have an automated and robust tool to create a pro forma, this is where you can build one in 5 minutes. Guess what? You can edit that one in 5 minutes and see how things changed. Next. Risk mitigation. Creating a new program or growing a new program involves investments. And the second we have investments, which means dollars on the table, there's a risk of that. that investment is going to take an effect right away if you want to start the program next year or so. So starting with a good, well-prepared pro forma can actually mitigate that risk because it exposes you to things that you may have not thought about. Have you thought about accreditors, for example? Have you thought about how many FTEs do you need? Have you thought about how much state appropriation you're going to get? All of these pieces in a well-prepared pro forma is going to uncover the ambiguity for a new program. Planning. Obviously, you need to budget for launching the program. Obviously, you need to budget for developing the new programs. You know, do you need new courses? Do you need new chair? Do you need a new program director? Is there a clinical part? Do you need to buy equipment? All of those pieces come into place when building a pro forma. Credibility. Current pro formas, as I mentioned earlier, they start with, let me find the average or let me find the median of this program size. So that's one way to do it. To increase your credibility, well, let's go into the advanced analysis now that they are available and somewhat usable, is to actually build a machine learning model. Same thing on the cost size. One second. Same thing on the cost. Launching a new program has this question, how much does it cost to teach? Because you don't know, you never had it. You could have a friend in a nearby college and you can give them a call. Hey, how much does that cost? That could be, but if you don't, then you're just going to be guesstimating or even find some numbers that may or may not apply to you. So finding some sort of benchmarking data that's going to be a good basis for your cost numbers are going to also be boost your credibility. Break even. The most important part of launching a new program is, well, there are many important parts. I take the word most back. So one important part is knowing when you're going to break even. Understand your ROI. Is this program going to be a cost generator all over, or is it going to eventually start to make some profit? Taking the credibility, taking the planning, taking the break even insights actually can help you go to your stakeholders and it's going to help you get approved. Next slide or next piece. When you go to the board to launch a new program, these people tend to have quite the long experience into launching new stuff, regardless of the domain they come from, whether it's academia or it's industry. They know how to poke holes in any proposal. And having a well-prepared pro forma can actually help you get approved quicker. So when building a pro forma, make sure to include the following. Next. Make sure to include an estimate of enrollment year by year. Now, how many years you go to the future is up to you. We find it to 6 to be a good number. So, and break it down. If you're going to get different tuition from out of state and in-state, try to break down your enrollment by those categories. Same thing, new programs mean new students, new programs mean new courses. Now, do you have the FTEs that you're going to need teach those courses? If not, then we need a year by year faculty, full-time and adjunct FTEs. Second thing you need to include is revenue. Pro forma means money to many people. And when you look into money, you look into the tuition, you look into the fees that you collect from the students, you look into the state appropriation if you receive any, if you're a public institution. And as you see year by year, now you're making your case of your forecast in the next 6 years. Whenever we say revenue, we have to mention cost. How much does it gonna cost to teach? How much does it gonna cost to market? Marketing budgets are not little, as we all know. And how much is it going to cost to develop the program and then administrator? You know, think about the program director that you're going to hire or the admin or the program assistant you're going to have. Calculate your marketing. I mentioned, if you don't have that number handy, make sure you calculate it correctly. Many times I see, whenever we see an estimated marketing per start, a marketing cost per start, I see people encompassing the non-incremental values in, like, oh, we paid $200,000 for our website. Well, technically speaking, that's non-incremental. So they're not going to increase as a cost for you every time you add a new student. So know your channels, how many starts you receive from those channels, and understand whether they're incremental or not. And eventually you're going to know how much is the cost per start. Whenever you have all those pieces ready, you'll be able to produce a break-even number. It's like, okay, I'm going to break even in year 3. You're going to be able to say, I'm going to get in year 6, going to get this many enrollments. And that's going to translate to this many revenue. And this is all nice. One of the things that whenever you create a pro forma is how static it is, or if you want to change something, you got to go and track that Excel sheet that the analyst from last year built, and you try to change a variable, and the entire Excel sheet goes down, and it's not working. So whenever you build, a pro forma, it gives you a flexibility to do an ad hoc change of numbers. So let's say I want to increase my tuition by 10% every year. If I input that, I want to see the results right away. Otherwise, it's going to be, okay, well, I'm going to wait a week for you to come back to me.
Great. Thank you. The last application we're going to talk about is generative AI. I'm sure this has been a hot topic for everyone lately. And the question is, how can it help at your institution? And one application that we consider generative AI help is really democratizing the data. And so what does that mean? It actually means making the data accessible, not only accessible to the person or the stakeholder who needs access to the data to make decisions, to help inform their decisions, but also make it accessible in a way that they can understand the data. And so there's one specific application is converting the data to a written report. Ultimately, it helps gain insight into the data without needing the technical capabilities of an analyst or the time required to do that. So, as I mentioned already, all of this definitely relies on the data, right? The AI models, generative AI, is only as good as the data that it sits on. And so you need to collect the right data. In many cases, you might have data that's spread out across multiple systems. The key to this is having it in a place where it can be queried from a single source. So if you're able to create a single source of your data, it will really help the creation of these potential automated reports. So data is number one. Number two is actually engineering the prompts. And I'm sure prompt engineering has been one of the most fastest searched terms in the last year. And for good reason. Without being able to talk to the data and talk to the LLM model, you won't be able to produce the results that you need to and relevant to the end user. So spending time to make sure that you're using the best prompt possible to get consistent, strong results is going to be important. You want to test this. You want to have manual reviews of this. As you'll find, starting to work with this, is the models can hallucinate, right? They can make up things that they think are relevant. And so again, going back to that prompting is making sure that you and the data, making sure all that's strong. And so when you're testing it, you can go back and say, okay, this showed up. Why did that show up? Okay, now let's edit the prompt and then retest it. And then ultimately, this gets to accessibility, right? You could have data in spreadsheets or other dashboards. And in many cases, it's hard to interact with. And so making it accessible through written text reports so someone can consume the information without having someone go in and look at the data, write up a whole report, is really where there's a lot of power in the ability with using generative AI. Right. So in summary, there's a lot of different applications, right? And this is what we went through is definitely not an exhaustive list by any means, but ultimately it can help you be very strategic and very comprehensive and robust, answering questions like, how does price and the value propositions that you focus on affect the demand for your programs? Where should you be targeting marketing or launching a new campus or a site or a regional site, and making sure that you're putting yourself in the best opportunity for your return on your investment from a financial standpoint, but also for your students? What skills are needed in the workforce, and do they align with what I teach? How many students will enroll next term or academic year, and how do I budget for that term? Are there different levers that I can pull to help either increase enrollment, or maybe I'm meeting my expectations? Ultimately getting to helping you identify what activities lead to higher probability of enrollment. Then when you're looking at new programs, how do you budget for those? What tools can you use and techniques can you use to make sure that you're putting your best foot forward for an estimate for program size, and then ultimately getting to the financials of that to understand the revenue potential, but also the cost. And then finally, how can you leverage the advances in artificial intelligence to make the data more consumable for end users, so that you can automate reports that are validated and true, so that the end users who need to make decisions can ultimately make those decisions with more information. All right, so that concludes our session today. If you'd like to learn more about any of the topics covered in our masterclass, we do have all of this information for you, the recordings, the presentations. We have additional avenues of learning about this through our Grow, Grow, Grow podcast. We also have our book, Start, Stop, or Grow. And then on a monthly basis, we do have our demand trends webcast. So we go over the most recent demand trends for both at the community college level, but also at the bachelor's and master's level as well. And those are actually this week. First one is tomorrow, and the second one is on Thursday. So thank you very much for joining today. Happy to follow up if you have any additional questions. Please reach out. Don't hesitate to do that. And thank you very much.